This is 8 Minutes, a podcast helping you understand the energy and climate challenge in just a few minutes. I'm your host, Paul Schuster. Decarbonizing buildings is one of the most important but challenging actions needed to address climate change. I've talked before on this show about some of the solutions emerging to do so, including heat pumps and building management systems. Today, I'm joined by Matt Rusteika of the Building Decarbonization Coalition to talk about a different technology solution that, frankly, I don't think gets enough attention yet. And that solution is thermal energy networks, a concept originally developed by HEAT, Home Energy Efficiency Team, and further taken up by Matt and BDC. These systems are interconnected, networked matrices of pipes and heat pumps that transform the heat from the ground beneath our feet or the thermal waste from commercial buildings into usable heat for residential homes and offices. This is still an emerging solution, but one that has a lot of potential to reduce the emissions from our built environment. As a reminder, check out our sister podcast, More Than 8 Minutes, for the full extended interview with Matt. 8 minutes. It's how long it takes the sun's rays to hit Earth, or how long it takes to do a full 8 minutes abs workout. Unless you're a Something About Mary fan and want to do that workout in 7 minutes. Let's get it on. Thermal energy networks haven't gotten as much press as their air-sourced heat pump cousins. Even geothermal solutions tend to get better coverage. But TENS are worth some consideration, not only because they can be a super efficient way to cover off on space heating or water heating, but because they can be a helpful tool to bring along local gas distribution utilities in the energy transition. But I'm getting ahead of myself. Let's have Matt explain what a thermal energy network is first.
What a thermal energy network does is it kind of harnesses that efficiency of the heat pump, and in so doing moves like a low-grade heat around that's enough to heat your water and to air condition and heat your space, but without having to actually combust anything. So what it is it's a pipe, a PVC pipe, that's set in the right-of-way of the existing gas utility. It looks almost identical to the pipe that you would use if you were building a gas network, 12-inch PVC pipe, except what's in it is water that is constantly kept at a lukewarm temperature, 65 degrees or thereabouts. And what the system does is it allows different buildings that have different kinds of heating load, or cooling load as the case may be, to either draw heat from that water or reject heat into it.
So thermal energy networks are more than just a matriced version of geothermal pipes. They can not only draw heat from the relatively constant temperature of the ground beneath us, but they are super efficient at recycling and repurposing that waste heat from commercial or industrial buildings, reusing that super valuable heat for residential homes rather than just wasting it. And that has implications.
So we're talking about a system that is more than 10 times as efficient as the gas furnace that's in many of these houses today. And it's because the difference between the single building ground source and the networked system, the thermal energy network, is that there really is just a lot of efficiency that you can capture by sending heat between buildings.
When we burn gas in our existing gas furnaces, we get about 85% heat out of every unit of energy that we consume. For air-sourced heat pumps, that efficiency can go up to 3 or 3.5 units of heat for every unit of energy. And for thermal networks, well, a college in Mesa, Colorado is tracking their TENS systems at over 8 units of heat for every 1 unit of inputted energy. Using the waste heat and recycling, that's a big part of why TENS can be so efficient. And so too are a series of boreholes that drill into the earth and store water that can be utilized as well.
You can, in these systems, draw heat from boreholes in order to balance the temperature in the pipe in case there's not enough waste heat. And in cases where there's a lot of waste heat, more than you can use, like if it was really hot in the summer, you can deposit heat that was rejected to the loop into boreholes during the summer, cap them off, and then use the heat that's been stored in the borehole, like a battery, in the winter when you need it.
How cool is that? Thermal batteries under our feet. And because of the massive efficiency that these networks obtain, well, all of a sudden, they start to check a whole bunch of boxes.
So what's happening with the thermal energy network is there may be you may be spending more money on infrastructure than you otherwise would have. But because you and I, if we had gas at our homes, would be paying in our bill half infrastructure and half gas, just about. Even if the cost of the pipelines grows by nearly 100%, you could still see a bill reduction relative to the gas scenario with a thermal energy network because there's no fuel.
Which makes these thermal networks very appealing for municipalities, especially because lower heating bills can be an appealing solution to help ensure a just transition to helping low and moderate income households participate in decarbonization. And then, the other benefit of thermal networks is their compatibility with traditional gas utility business models. It's undeniable that decarbonization is going to test gas distribution company strategy, and maybe TENS are something of an answer.
Because there's been this huge question about whether and how gas utilities would align their activities and business model with the zero emission future that is not only a desirable thing for Massachusetts, but is in fact in the law. What a gas utility does is not sell gas. That is a pass-through cost for them. What a gas utility does is build infrastructure. And so there are tens of thousands of miles of natural gas main under the streets of Massachusetts all over the state. There are 1.3 million miles under the streets of the United States as a whole as of last year. And those aren't going to just disappear. That gas company, if it can't find a way to adjust to a future where we cannot burn gas or distribute gas because the methane in the gas itself is a greenhouse gas, then that it makes it impossible to move forward.
Because these thermal networks use the same right-of-way, the same franchise agreement, the same workforce, it gives gas distribution companies a way to support decarbonization. But despite the benefits of these networks, only a handful of pilot projects have been built in the US so far. What's holding the industry back? Well, for one thing, ripping up old networks of existing gas infrastructure can be time-consuming for all of the permitting and siting, but there are also some fundamental legal problems to get around as well.
So in order to roll them out at scale, we need to change laws that exist in almost every state that explicitly limit gas utilities to selling gas. Gas utilities franchise from the state, their right to operate as a monopoly utility is limited to selling gas.
Those obligation to serve laws are going to need to change regardless of whether TENS is the preferred solution or not. But until they do, these TENS networks are being rolled out far slower than they otherwise would. And the reality is that these are really interesting, unique solutions that, as Matt puts it, check a lot of boxes. We just need more use cases to showcase their benefits.
I think once people see and feel for themselves how much better this stuff is, how much better the electrification technology is, once they see that it can do things that gas just can't do, then you'll get to a place where the consumer demand for the technology in question becomes almost like consumer demand for indoor plumbing.
I'm Paul Schuster, and this has been your 8 Minutes.